Gases can be described using properties such as pressure, volume, amount of a gas in moles, and the temperature. There are three simple laws that we use to describe gases. We have Avogadro's law, which is the relationship between the number of moles of a gas and the volume. As the number of moles of gas increases, so does the volume. So the relationship between amount of gas in moles and the volume is directly proportional, which means that if the number of moles of a gas decreases, so does the volume. Then we have Boyle's law. In Boyle's law, we see the relationship between pressure and volume. So the relationship between pressure and volume is inversely proportional, which means that if the pressure is increasing, the volume is decreasing. And the other way around, it's also true. When the pressure is decreasing, the volume is increasing. And then the third one is Charles' law, which is the one that we're going to be looking at in this experiment. For Charles' law, we're looking at the relationship between temperature in kelvins and the volume. The relationship between temperature and volume is directly proportional. So whenever we're looking at the relationship between two things, like for example, the temperature and the volume, if we're looking at the relationship between temperature and volume, it means that the other two properties, they have to remain constant. So we have the equation PV equals nRT. So for Charles' law, we're looking at the relationship between the temperature and the volume, temperature and volume. So to look at the relationship between those two, we need to keep the number of moles, which is the amount of the gas, and the pressure constant. So we have the equation here that compares two states of a gas sample. V is for volume, T is for temperature. So you have an initial state and then you have a final when you have V2 over T2. So I have here an example. If we have a balloon at 300 kelvins, temperature is always in kelvins. The volume for that balloon is determined to be 600 liters. We can actually calculate that constant, the volume divided by the temperature. With this example, you're getting 2 liters per Kelvin. So now if we look at the right side, when I have my balloon, if the temperature increases from 300 to 600 kelvins, which is twice as much, the volume will be twice as much. So instead of having 600, we're going to have 1200 liters. So you can calculate K again, which is your volume over the temperature, and that will give you exactly the same thing, a constant. So the procedure for this experiment: first you need to set up a ring stand, a hot plate, and you're going to use a beaker, a 400 milliliters beaker. Put halfway of that beaker with tap water, and you're going to start heating up that water. You're preparing a hot water bath. And then you're going to find a plastic tray, and in that plastic tray you're going to add a mixture 50-50, half and half ice and water. You're going to find an Erlenmeyer flask, a rubber stopper, and your rubber stopper already contains a rubber tubing. So you have like a piece of rubber from your rubber stopper that connects the inside of your flask with the outside. You're going to press your rubber stopper into the flask until it holds in there. Okay? So you don't press it too hard that you're not going to be able to take it out, but hard enough that it will stay permanently in your Erlenmeyer flask until you're ready to remove it. Now you're going to find a wax pencil and you're going to mark the bottom part of your rubber stopper. You're going to use on top of the glass for your elevator flask. You're going to trace a line. Where the rubber stopper ends, you're going to trace a line marking that on your elevator flask. So I will show you in class. Make sure that the elevator flask that you're using is dry. If it's wet, just use a paper towel and make sure that you dry it out. So now we're going to clamp the flask to the ring stand, and you have your flask with the rubber stopper. And remember, like, you should have mark the bottom of your rubber stopper using a wax pencil on the glass on your elevator flask. So you have your glass clamp to the ring stand, the boiling water, and you're going to slowly decrease the height of your clamp with the flask, or you're going to move down the flask until the flask is inside the boiling water. With the flask in the boiling water, now you're going to time it for 6 minutes. When the time is at 4 minutes, you're going to put the thermometer inside the boiling water and you're going to leave it there. You need to record that temperature. So we're going to wait until the 6 minutes. When the time is at 6 minutes now, the thermometer is inside the water, but we're going to focus on the flask. So at 6 minutes, you're going to use a small clamp to clamp the rubber tubbing in your rubber stopper. So you have your rubber stopper with a small tubbing that connects the inside of the flask where the air, which is your sample, is trapped, okay? And you're going to clamp that piece of rubber tubbing, okay? So trapping the air inside of your flask. So after you have clamped your rubber tubbing, you're going to now move the flask outside of the boiling water. Okay? You have reached your 6 minutes, so you're going to move the flask outside of the boiling water. And actually, you're going to remove the clamp, holding the flask with the clamp. So you're going to remove it from the ring stand, and you're going to keep using that clamp to move your flask around. Remember, the flask is hot, so you're using the clamp to move it around. The clamp that I'm referring is not the clamp that it's holding your piece of rubber tubbing. It's the clamp that you're using, the one that I have with the pink line. It's the clamp that you're using to connect the flask to the ring stand. Okay? So that clamp is a big clamp. So that's the one that you're using to move the flask around. So you're going to remove the flask from the boiling water all the way out of the ring stand, and we're going to keep using that clamp to move the flask around. At some point, please record the temperature of your boiling water. Write it down in your lab book, page 145. So now you have your plastic tray with the mixture ice water, and you're going to put your flask inside of the ice water bath. You're going to make sure that you're holding your flask down using the clamp. This one right here. Remember, your small clamp is just used to close your piece of rubber tubbing that is connecting the air inside of your flask. So you're going to hold your flask down under the water. Okay? Make sure that that piece of rubber tubing that you have in the rubber stopper, it's under the water. Okay? So you're going to hold that flask under the water for 4 minutes, so you have to time it. So it's 6 minutes in the boiling water. After your 6 minutes, you're going to clamp the rubber tubbing, you're going to remove it from the ring stand, and now you're going to hold that flask under the cold water, making sure that that piece of rubber tubbing is under the water. After your 4 minutes, now you're going to remove that small clamp, the one that I have in yellow, that one. holding the flask under the water, making sure that that piece of rubber tubing is under the water. You're going to carefully remove that clamp, and I mean carefully because you don't want the rubber stopper to come off the flask, okay? You just want to remove the clamp from your piece of rubber tubing so water will get into the flask, okay? There's a change in pressure due to the decrease in temperature, so water will be pulled inside the flask, okay? So at 4 minutes, you're going to remove that yellow, the clamp that I have here in yellow. Remove and keep the flask under the water until you feel that the water stops coming into the flask. After that, now you can actually remove the flask from under the cold water. Remember, that's at the mark for 4 minutes. At 4 minutes, you're removing the clamp. You're waiting until the water stops getting into the flask, and then you can remove the flask from the ice water bath. You need also to write down the temperature for your ice water bath. So put the thermometer, wait until the temperature remains constant, and write down the temperature in your lab book. So you're going to dry the outside of your flask. Use paper towel. Make sure that you dry the outside of your flask, but make sure that when you're drying the outside of your flask that you don't erase that mark that you did in the beginning. So now you can remove the rubber stopper, and you're going to transfer the water that came into the flask. When the flask was under the cold water, remove the rubber stopper, transfer the water into a graduated cylinder, and record the volume. So when your flask is under the water, right, it was at a hot temperature because it was in boiling water for 6 minutes. Now you're putting the flask under your cold water, ice water mixture. The temperature is decreasing in your flask. So when you're removing that clamp from your rubber tubing, water is going to get into the flask, pushing air out because the temperature is decreasing. So the volume of air in your flask is going to also decrease. That volume is decreasing because it's been replaced by the water that is pushing out the air, getting into your flask. So record the volume of the water inside the flask, transfer the water in your graduated cylinder, and copy the number in your lab book. Now we need to know the volume for the whole flask, and you might think that if the flask says that it's like 100 milliliter, that's the total volume. No, that's the total volume that you can measure with the lines on the side of your flask, but the total volume is different. So to measure the total volume of your flask, which is the total volume of air, remember your gas sample is air. So we're assuming that the whole flask is filled with air, but we cannot measure that volume. So we're using water to determine the actual volume for the entire container. So you're going to fill your flask with tap water all the way until you see water forming like a bubble on top of the top part of your volumetric flask. Okay? So you have so much water that it's almost coming out of the flask. So put some paper towel on top of the table so you don't make a mess because you're going to spill some water. So fill the flask, and now you're going to use the rubber stopper that you have been using since the beginning. You're going to put the rubber stopper back into your Erlenmeyer flask. So some water will come out of the flask, and that's fine. Make sure that when you're doing that, you don't trap any air. If you have some bubbles inside of the flask, remove the rubber stopper, add more water, and try it again. If you trap some air, now that air is occupying volume in your flask that you cannot measure. So Put the rubber stopper until the bottom of your rubber stopper is aligned with the line that you did in the beginning using the wax pencil. Align them. Some water will come out, that's fine. Make sure that you don't have any air. And now you can determine the total volume by measuring the volume of the water that you're using inside of that flask. So remove the rubber stopper and now transfer the water into a graduated cylinder. You're using a 100 milliliter graduated cylinder and the volume is larger than that. So you're going to fill your graduated cylinder all the way to 100, write it down. Now you can pour that water down the drain and you have your graduated cylinder empty and transfer the remaining water that you have inside of the flask. Now you're going to add your two volumes. You have 100 milliliters plus whatever amount you have remaining in your Erlenmeyer flask. You're measuring that amount, you're adding everything together, and that will be the total volume for your flask. So right now you have 4 data points in your table. You have the temperature for the hot water, right? At 4 minutes, you're placing the thermometer, and then after you remove the flask, you're going to look at the temperature. You're going to copy that temperature for the boiling water. You have the temperature for the ice water bath. You have the volume of the water that got into the flask when it was under the ice water bath, and you have the total volume for your flask. Okay, so those are your 4 data points: 2 volumes, 2 temperatures. Now everyone is going to have the same atmospheric pressure. We're going to use the barometer that is in the lab room to determine the pressure for at that moment, and everyone will use the same number. So now we have 2 temperatures, hot and cold water, 2 volumes, the total volume and the volume of the water that got into the flask, and a pressure. And those are the numbers that we need to complete the calculations. After you're done with everything, put everything back to the original location. Okay, dry your Erlenmeyer flask and leave them on the trays.